Hello everyone, welcome to aplusbi. If you come from Cyber Math, say hi. Cyber Math is another channel that I have, which is basically focusing on algebra and number theory, a tiny bit of geometry here and there. But anyways, this channel is about complex numbers. Did I say that? Okay, hopefully I did, but if I did not say that, this is aplusbi. Welcome to aplusbi, and this channel is all about complex numbers. So z is a complex number. What is a complex number? Z equals a plus bi, where a and b are real numbers, and I is the square root of negative 1, or you can say I squared equals negative 1. That's probably safer to say, right? If you're new to complex numbers, go ahead and check out my lecture videos. All right, let's get started. So if you have an equation like this, z squared plus 1 equals z squared divided by z squared plus z plus 1, and we're going to be solving for z values, a lot of z's, and second powers. When we multiply, guess what we're going to get? A Quartic equation, a fourth degree. And on the other channel that I have, we just talked about Cyber Math. If you haven't checked it out, go ahead and check out my video, because I made not a Quartic, but a hexadecic problem with lots of interesting solutions. How many? Go ahead and find out. So, to be able to solve this problem, we could replace a z with a plus bi, but I don't think it's going to be very helpful. I think we should multiply both sides by z squared plus z plus 1. One thing to keep in mind though, whenever you have fraction, you always have to check for the domain, because you don't want the denominator to be 0. So we don't want z squared plus z plus 1 equals 0. Wait a minute, this can never be 0. Well, that's only true for real numbers. If z is non-real, this can be 0. So you don't want that. And where do they come from? Okay, you want to find out? You can solve this with the quadratic formula. That's going to give you negative b plus minus square root of 3i divided by 2. You can separate it, but these are cube roots of 1. Why? What does that mean? If you take this equation and multiply both sides by z minus 1, which is another problem within a problem, right? We're kind of doing two problems in one. That's a bonus. And this gives you z cubed minus 1 equals 0. So from here, you're basically finding cube roots of 1, but the z does not equal 1, because that's something we introduced. It was not in the original problem. We introduced it, so that's like an extraneous solution, okay? Because z equals 1 does not satisfy this, right? So any cube root of 1 besides 1 is going to be a solution. So we need to make sure z is not one of the cube roots of 1, except for 1. Z can be 1, but 1 is not a solution, is it? Plug it in. It's not. So no cube root of 1. We can safely say that, okay? Cool. Under these conditions, let's go ahead and solve the problem. What is the method? Cross multiplication. How do you cross multiply? Multiply this by that, and that equals this. Get it? Circles and then a box. It's not circles, but they call it circle. Like when you do something like, suppose I have z squared minus 1, right? Okay, let's circle it. That's not circling, it's ellipsing it, but I don't know. Anyways, so let's copy the problem here. Z squared plus 1 equals z squared divided by z squared plus z plus 1. So that's the wrong term to use, but that's okay. Now, if you cross multiply, you're going to get this times the denominator equals z squared. Wow, that's interesting. Can I factor this? Probably not, but why don't we just distribute the whole thing? Let's see what happens. That's usually the first approach you should take. Let's see what happens. What if I do this, right? Don't just stay with what ifs, just do it. Z to the 4th plus z cubed, I'm just distributing, plus z squared plus z squared again. I got a duplicate. That's okay. There's a reason why you have a duplicate, because one of them will be poof, gone. Z squared canceled, bye-bye. Now we end up with something super duper nice. You know why? Because you'll see, okay? I'll explain that. So if you go ahead and write the remaining terms, you get something awesome. This is a really nice equation. You know why? For a couple of reasons. One is this is solvable. Isn't that amazing? I mean, we can solve it. We can find the roots. Great. The second reason is we can do this in more than one way. So let's go ahead and take a look at both methods. So it's kind of like a problem within a problem, okay? So let's see. Oh, by the way, when we solve it, we always need to make sure z squared plus z plus 1 is not 0. But that would imply if this is 0, the rest should be 0, but we know that's not going to happen when z squared plus z plus 1 is 0. Because when z squared plus z plus 1 is 0, z squared z cubed, oops, sorry. When this is 0, z to the 4th plus z cubed, which is z cubed plus z plus 1, cannot be 0, because this can only be 0 for 0 and negative 1, but 0 and negative 1 are not solutions. You see what I'm talking about? Am I making it too complicated? I hope not. Anyways, let's forget about it, and now let's focus on solving this problem. How do you solve it? First method is you divide everything by z squared. You know why? Because it's in the middle. Let's do it. Divide by z squared, divide by z squared, divide by z squared. Remember that. Divide by z squared, divide by z. Keep saying it to yourself. Okay? People are going to think you're insane. Now, we're going to put these two together. Awesome. They just go well together. Look at that. Isn't that a beauty? That's awesome. That's math. Now, we're going to do the following. This one and this one will be separated. But guess what? This one is actually can be written in terms of that one. What does that mean? If you square z plus 1 over z, you get z squared plus 1 over z squared plus 2ab, but ab is 1, so it's 2. Nice. We can now write this as the square minus 2. In other words, this guy here will be z plus 1 over z squared minus 2 plus z plus 1 over z. Keep that in parentheses because we are about to do something. Let's go ahead and fix this first. We got to add like terms because they like each other. Negative 2 and 1. Let's gives us negative 1. Awesome. Now take a look at this. Take a good picture. I said that one more time today. Z plus 1 over z repeats. What does that mean? Substitution. S for substitution. Always use it. It's just awesome. So now I can probably go ahead and call this maybe w because it's supposed to be a complex number. And we get w squared plus w minus 1 equals 0. Awesome. Actually, the results are real. For real? Yes. Let's find out. You know how I know? A and C have opposite coefficients, so delta will be positive for sure. Think about it. B squared minus 4ac. If AC is negative, you're guaranteed a positive delta. What is delta? Look it up. Okay, it's the discriminant. So negative b plus minus the square root of b squared minus 4ac, that's a 5. Uh-oh, I smell golden ratio or something like that. And this gives us two solutions. Great. Can I just stick with one? Because, you know, I'm lazy. You know that, right? Already, hopefully by now, you realize. But I'll just take the easy route. And the rest will be your exercise. Please, come on, do some exercise. You do need it, right? It's going to make you better. So let's just take this one, okay? What is w? W is z plus 1 over z. So z plus 1 over z is equal to this one. How nice. And then from here, we're going to multiply everything by z. Z squared plus 1 equals this number. Not the golden ratio, but pretty close. You know, maybe it's the 1 minus golden ratio, I think, right? Something like that. 0.68 something or 0.618 something. I don't know. Something like that. From here, we get a really nice, just kidding, a somewhat nice quadratic equation. Not very nice, but anyways. We can solve it, not too hard. Quadratic formula, negative b plus minus the square root of b squared. Uh-oh, I'm going to square a radical, too bad. Minus 4ac, that's just going to be a minus 4. Hopefully this becomes positive, right? Is it going to be positive? I don't think so. Because in order for this to be positive, the square root of 5 minus 1 over 2 squared needs to be less than 4, which means the inside needs to be greater than 2, which means root 5 minus 1 is greater than 4, which means root 5 is greater than 5, which is false. So everything's false, falls apart, okay? So what do? Use complex numbers, imaginary numbers. But this gives you two solutions. The other two are going to come from the other w. You can do that, right? Hopefully. Because I need to show you an alternative method, which is the second method. And the second method is just awesome. You know why? Because it uses a really good idea. First of all, if you are familiar with complex numbers, you're probably going to realize, when do we get a 0 by adding powers of z? These are all roots of unity except for 1, because 1 plus 1 plus 1 plus 1 plus 1, did I say 5 times? Does not equal 0. But guess what? If we do a little bit of magic touch or hocus pocus or abracadabra or mathemagic, you get the following. Multiply by z minus 1 again. We've done this before, right? And you get something super duper amazing. That is going to be z to the 5th minus 1 equals 0. Z to the 5th equals 1. Yay! Fifth roots of unity. Of course, I told you that's an identity, right? You probably knew that, maybe. So what are we getting from here? We're going to find fifth roots of unity, but we got to make sure z does not equal 1 because it doesn't satisfy the original problem. All right, how do you find it? You can write the 1 as e to the power 2 pi ni, and then you get z to the power of, make sure n does not equal 0, so you don't get 1. Or should I maybe exclude it later? And from here, if you raise both sides to the power 1/5, in other words, find the fifth roots of unity, you're going to get the following values. N equals 1, 2, 3, and 4. Don't use 5 or don't use 0 because that's going to put you back to square one. I mean, just back to 1, which is not a solution. So these are going to be the solutions. And did I include a graph? Hopefully I did. Yay! What does the graph mean though? They don't intersect because there are no real solutions. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out CyberMath, and bye-bye.